example, this one says a current galvanometer has the following parameter: B 10 times 10 raised to power minus 3 Weber meter squared. That's B. This B means magnetic flux density. This B means magnetic flux density. So the current galvanometer has the following parameter. One of the parameters that it has is the magnetic flux density, which is B, that is given here, and the N here is number of turns. The N here is number of turns, the L is the length, and the D is the distance, and K is the constant. So it has its own formula, and I will show you while solving this. So let me just read it. I just wanted to explain what this means. Don't forget this one. The first one here is the magnetic flux density, and this one number of turns, and this is the length, distance, and this K is the constant. So moving forward, we have the parameters that is given here. The question here says calculate the deflection of the galvanometer when a current of 1 microamp flows through it. So here solution. Given that, so these are the parameters that is being given here. I convert it, like for example this one, this B, I convert it to I remove this minus 3, I convert everything, and this one from millimeter to meter, millimeter to meter, to meter here, and this is the constants that is given from microamp to raised to power minus 6. Then firstly we have to solve for area of coil. Area is equal to I'll be a little bit fast in this one, times the density. So area times distance rather. So the length times distance, length times area is equal to length times distance, length times distance. I don't know, this one I'm making mistake here and there. 0.016 times 0.016, that will be area A will be equals to 2.56 times 10 raised to power minus 4 meters squared. Area is in meters squared. You can don't just watch, stay with your calculator. Anything you're doing, just confirm it, try and do it also. When you finish watching the video, go back, try do yourself, solve the question yourself, then come back and check whether you have the answer. And since we have solved the formula, then we look for the deflection. This is the deflection formula. Deflection formula, which is theta will be equals to N. This is N, not micro. N times B times I, which is current, times area, all divided by the constant that was given. So theta here will be N, which is 200. Okay, let me solve it one after the other. The first one, the numerator. Let me solve the numerator first. 200 N, which is 200. I'm solving this one first. 200 times 0.01, number of turns, times B. B is given here to be 0.01, number of turns times B times the area. Area we also solve here to be area is solved here to be 2.56 times 10 raised to power minus 4, and times what else? Current. Oh, I supposed to bring current before area, but there's no problem there. Current 1 times 10 raised to power minus 6. So solving that, do your normal calculation. The numerator there will be 5.12 times 10 raised to power minus 10. So bringing it to the formula that was this one, I just solved for this one. This is it. I just solved for this one, which is the answer. So the theta here, theta will be equals to, bringing the formula that I just solved for the numerator, 0.2 times 10 raised to power minus 10, all divided by the constant, which is k. K was given to be 12 times 10 raised to power minus 7. So theta here will be equals to 5.12 all divided by 12 times 10. I'm bringing out these two 10. This times 10 raised to power minus 10, and this one minus 7. So minus 10 plus 7, that will be 3, minus 3. That's what you have there. Then you do normal division here. You have your theta to be equals to 0.12 divided by 12. That will give you 0.427 times 10 raised to power minus 3. Please use your calculator. I used my calculator. Then theta will be equals to 4.27. This is the answer, but I just want to make this to come first. This is the correct answer. If you leave it like this, as far as this one is minus 3, you are correct. But I just want to bring this 4, like add minus 1 to this 2, so that it will be minus 4, and I'll bring this 4 out. That will be times 10 raised to power minus 4. The unity is under radian. Just give it rad. So that's the answer to the question that was given here. Thank you for watching. I really appreciate you staying. Always come around. I'll be dropping other videos.